Good morning, students. My name is Vijay Piraga. Today we are going to discuss about nucleophilic substitution reactions. Nucleophilic substitution reaction. So first, what is substitution reaction? What is substitution reaction? Substitution reaction means in a molecule, one atom or group or ion get replaced by another atom or group or ion. Those reactions are called as what? Substitution reactions. Here AB is a molecule, it is reacting with C reagent, and in the product what happens? This B atom gets substituted by C. So the product will be AC plus B. Okay, so here what happened? B atom get replaced by C atom. Okay, and the formed product is AC plus B. Okay, this type of reactions are called as what? Substitution reactions. This type of reactions are called as what? Substitution reactions. Okay, in substitution reaction is what? One atom or group or ion present in a molecule get replaced by another atom or group or ion. This type of reactions are called as what? Substitution reactions. These reactions are called as what? Substitution reaction. Okay, what is nucleophilic substitution reaction? Nucleophilic substitution reaction means if a substitution reaction is initiated by, is started by a nucleophile, a reagent called nucleophile, then that substitution reaction is called as what? Nucleophilic substitution reaction. If a substitution reaction get initiated by nucleophile, then that reaction is called as what? Nucleophilic substitution reaction. You may ask that what is nucleophile, sir? Nucleophile means it is a electron rich species. Nucleophile means what? Electron rich species which contain surplus number of electrons, which is electron rich species which have more number of electron pairs, which can donate electron pairs, which have lone pair of electrons. Okay, so those type of species are called as what? Nucleophiles. For example, ROH. In oxygen atom, on oxygen atom, electron pairs are there. ROH, RNH2. Okay, Cl minus, all negative charged species. Okay, so these are the examples of nucleophile. Nucleophile means which have more number of electrons, surplus amount of electrons, which is electron rich species, which have the ability to donate electron pairs. Okay, so those species are called as what? Nucleophiles. Okay, if a substitution reaction is initiated by, is started by nucleophile, then that substitution reaction is called as what? Nucleophilic substitution reaction. Okay, so the substitution reactions of alkyl halides. The substitution reactions of alkyl halides are nucleophilic substitution reactions. Okay, so the substitution reactions of alkyl halides are called as what? Nucleophilic substitution reactions. Okay, for example, alkyl halide is there. Alkyl halide reacts with the nucleophile, and this halide group gets substituted by nucleophile and lead to the formation of RNU plus X minus. Okay, so these reactions are called as what? Nucleophilic substitution reaction. Okay, so this halide group is substituted by nucleophile. Okay, so this type of reactions are called as what? Nucleophilic substitution reactions. Okay, and the reactivity order of alkyl halides will be like this: Ri, alkyl iodide greater than alkyl bromide greater than alkyl fluoride greater than alkyl fluoride. Here the reactivity will depend upon, reactivity is directly proportional to bond length. Reactivity is directly proportional to which one? Bond length. Okay, so as the bond length increases, reactivity increases. That's why alkyl iodide readily participate in the nucleophilic substitution reaction. Then alkyl bromide readily participate in the nucleophilic substitution reaction. Then alkyl chloride readily participate in the substitution reaction than alkyl fluoride. Okay, so this is the reactivity order of alkyl halides in nucleophilic substitution reaction. Okay, so there are two types of nucleophilic substitution reactions are there. How many types are there? Two types of nucleophilic substitution reactions are there. Okay, so one by one we will discuss in detail. Okay, see here beta. So there are two types of nucleophilic substitution reactions are there. One is SN1 reaction, another one is SN2 reaction. SN1 reaction, another one is called as what? SN2 reaction. SN1 means unimolecular reaction. It is called as what? Unimolecular reaction. Unimolecular reaction. SN1 reaction means what beta? Unimolecular reaction. Substitution nucleophilic unimolecular reaction means the concentration or the rate of reaction will depend upon only one substrate molecule. That's why it is called as what? Unimolecular reaction. SN2 reaction is bimolecular reaction, means here the rate of reaction will depend upon the two substrate. One is alkyl halide concentration and nucleophile concentration. Okay, so that's why it is called as what? SN2 reaction. It is called as what? Bimolecular reaction. Okay, so there are how many types of nucleophilic substitution reactions are there? Two types. One is SN1 reaction, another one SN2 reaction. SN1 means substitution nucleophilic unimolecular reaction. SN2 means substitution nucleophilic bimolecular reaction. Okay, so we will discuss one by one. Okay, first we discuss about SN2 reaction. First we discuss about which one? SN2 reaction. What is SN2 reaction? SN2 reaction. Just now I told you SN2 reaction means it's a which reaction? Bimolecular reaction. It's which reaction? Bimolecular reaction. So SN2 reaction is bimolecular reaction in which the rate of reaction is depend upon the concentration of alkyl halide as well as nucleophile. Okay, so here in the SN2 reaction, the rate of reaction is directly proportional to the concentration of alkyl halide as well as nucleophile. That's why it is called as SN2 reaction. It's a which reaction? Bimolecular reaction, means here the rate of reaction will depend upon two components. One is alkyl halide concentration, another one nucleophile concentration. It's a second order reaction. It's a which reaction? Second order reaction. So SN2 reaction is which reaction? It's a second order reaction. If we observe the mechanism, here what happens in the SN2 reaction, the bond breakage and bond formation take place in single step. Without forming any reactive intermediate, the reaction completes. Okay, SN2 reaction occurs in only single step. The bond breakage as well as bond formation. Bond breakage as well as bond formation take place in single step without forming any kind of reactive intermediate. This reaction, SN2 reaction, completes. Okay, see here, if suppose CH3Cl is there. CH3Cl, methyl chloride. Okay, so react with the nucleophile. Any nucleophile, it may be OH minus ion, it may be alkoxide ion, or it may be cyanide ion. Okay, so this nucleophile attacks the carbon atom from the back side. Okay, so and lead to the formation of one intermediate transition state. Okay, so Nu, carbon, hydrogen, and at the same time this one. So this intermediate state is formed. Intermediate stage is formed, and in the final step it will lead to the formation of product. Okay, so here Nu and H plus Cl minus. Okay, so this is the mechanism of SN2 reaction. Here nucleophile attacks the carbon atom from the back side, exactly opposite to that of chlorine atom. and results in the formation of one intermediate stage. Unstable intermediate stage is formed in which nucleophile and chlorine atom, nucleophile as well as chlorine atom, both are partially bonded with the carbon atom. Here carbon is pentavalent. Okay, so it lead to the, when nucleophile attacks the carbon atom from the back side, it lead to the formation of intermediate state. In the intermediate state, both the nucleophile as well as chlorine atom, both are bonded with the carbon atom partially. So in the intermediate state, what happens? This chlorine atom take back its electron pair through which bonded to the carbon atom. At the same time, this nucleophile will offer electron pair to the carbon atom for the formation of bond. Means here the bond between carbon and chlorine will become weaker, and at the same time the bond between nucleophile and carbon becomes stronger, more and more stronger. Okay, here the chlorine will attract the electron pair and it will prepare starting to leave from the molecule. At the same time, nucleophile will offer electron pair to the carbon atom and starts formation of bonding. Okay, so in the final stage, what happened? Cl- leaves from the molecule and nucleophile get replaced the position of chlorine atom. Okay, so this is the mechanism of SN2 reaction. Here what happens? Walden inversion. Here Walden inversion or umbrella inversion is formed in the SN2 reaction. Okay, so the configuration of formed compound is exactly opposite to the configuration of alkyl halide. So the carbon atom which is formed in the reaction have exactly opposite configuration to that of alkyl halide. Okay, so the inverted product is formed in the SN2 reaction. So the inverted product is called as Walden inversion or umbrella inversion. Okay, Walden inversion or umbrella inversion is formed in the SN2 reaction. We'll see here. We'll see here. Okay, see here, this assume that this is a nucleophile and it is reacting with the alkyl halide. Okay, so in the reaction what happens? It attack from the back side, that's why its inversion is changed. Okay, and this is leaving nucleophile, this one is inverted product, okay, so this one is substrate molecule. Okay, so this type of stereochemistry is seen in the SN2 reaction. Here in the SN2 reaction, inverted product is formed. So this inverted product is called as Walden inversion. It is called as what? Walden inversion or it is also called as umbrella inversion. Walden inversion or it is also called as umbrella inversion. Why it is called as Walden inversion or umbrella inversion? Why it is called? Because the configuration of carbon atom under attack is inverted in such a way as umbrella turns inside out when it caught in the strong wind. Okay, so like umbrella turns inside out when it caught in the strong wind, like that only the configuration of carbon atom also inverts, because here nucleophile is attacking from the back side. So due to the presence of leaving group, the nucleophile in the SN2 reaction, the nucleophile will attack the carbon atom from the back side. That's why the product have inverted configuration. Okay, so the product present in the SN2 reaction have the opposite configuration. to that of alkyl halide. Okay, so this inverted product is called as what? Walden inversion, or it is also called as umbrella inversion. Walden inversion, or it is also called as what? Umbrella inversion. Here nucleophile is attacking the substrate molecule. Assume that it has this type of configuration in the beginning. Okay, so while it attacks from the nucleoside, its nucleophile attacks from the back side, its configuration inverts. So this is the substrate configuration in the beginning, and in the product it has this type of configuration. Means what happened? The configuration of carbon atom under attack is inverted. Okay, so this inverted product is called as what? Walden inversion or umbrella inversion. Okay, so this type of stereochemistry is seen in case of which reaction? SN2 reaction. Now, what is the order of reactivity in the SN2 reaction? Which alkyl halide take part readily in the SN2 reaction? Okay. So, if you see the order of reactivity, it will be like this. Here, there is no intermediate is formed in the SN2 reaction. Okay, so that's why the order will be methyl bromide greater than ethyl bromide greater than isopropyl bromide, or we can call it as halide, isopropyl bromide, and after that neopentyl bromide, or we can take any halide, neopentyl bromide. After that tertiary butyl bromide. After that allyl halide. After that benzyl halide. Okay, so this is the reactivity order in case of SN2 reaction. Okay, so the primary alkyl halides readily participate in the SN2 reaction. Okay, so this methyl bromide, ethyl bromide, these type of alkyl halides readily participate in the SN2 reaction. Why? Because there is no sterically hindrances there. There is no reactive intermediate is formed. That's why the primary alkyl halides readily participate in the SN2 reaction, while tertiary alkyl halides do not take part in the SN2 reaction. Okay, so this is the reactivity order. And as the strength of nucleophile increases, the rate of SN2 reaction also increases. As the strength of nucleophile increases, stronger the nucleophile, faster will be the rate of substitution reaction. Okay, so as the strength increases, for example, the nucleophiles like trialkyl phosphide, okay, bisulfide, okay, thiol, okay, cyanide, alkoxy. So this type of nucleophiles, if this type of nucleophiles are participated in the SN2 reaction, then the rate will be very faster. The rate of SN1 reaction, SN2 reaction will be very faster. Okay, so as the strength of nucleophile increases, the faster will be the substitution reaction. Okay, and also in case of leaving group, as the ability of leaving group increases, the rate of substitution reaction also increases. The leaving groups like I minus, Br minus, okay, so the order will be I minus greater than, Br minus greater than, Cl minus greater than, F minus. Okay, so better the leaving group, faster will be the reaction. Okay, and in case of SN2 reaction, we use non-polar solvents. We use which solvents? Non-polar solvents. Okay, so non-polar solvents favors the SN2 reaction. Weak polar aprotic solvents also favors the SN2 reaction. Okay, so this is about which reaction? SN2 reaction. Okay. Next, we will discuss about SN1 reaction. So what will happen in case of SN1 reaction? Okay, so in case of SN1 reaction, okay, so here SN1 reaction. SN1 reaction means it's a unimolecular. As I told in the beginning, it is which reaction? Unimolecular reaction. SN1 reaction is unimolecular reaction. Here rate of reaction is directly proportional to the alkyl halide concentration. The rate is directly proportional to which one? Alkyl halide concentration. Here it is called as what? Unimolecular reaction. Okay, so in the substitution nucleophilic reaction, in which the rate of reaction only depend upon the alkyl halide concentration, not on the nucleophile concentration, then that reaction is called as what? SN1 reaction, substitution nucleophilic unimolecular reaction. It's a first order reaction. It's a which reaction? First order reaction. So it's a first order reaction. It's a first order reaction. It is also called as unimolecular reaction. In this reaction, the rate of reaction only depend upon the alkyl halide concentration, not on the nucleophile concentration. Okay, so this type of reaction is called as what? SN1 reaction. Okay, so this SN1 reaction occurs in two steps, where we see SN2 reaction occurred in only single step. Here SN1 occurs in two steps. Okay, we'll see one by one. Here, if you see the mechanism, step 1. In the step 1, what happens? Heterolytic fission take place. Heterolytic fission take place and leads to the formation of carbonium ion. Okay, so here heterolytic fission take place in presence of polar solvent. Okay, so this step is slow step and rate determining step. Slow step and rate determining step. Here what happens? Carbonium ion is formed. Okay, so in the SN1 reaction, what happens? Carbonium ion is formed in the SN1 reaction. Okay, so here due to the heterolytic fission, carbocation or carbonium ion is formed. Okay, so this reaction is slow step and rate determining step. Okay, so in the rate determining step, only one reactant is participated. That is alkyl halide only. That's why the rate of reaction only depend upon the alkyl halide concentration. That's why it is called as what? Unimolecular reaction. Okay. So the rate of reaction only depend upon which one? Alkyl halide concentration, because only alkyl halide is participated in the rate determining step. That's why this reaction is called as what? Unimolecular reaction. Okay. So in the step 1, carbonium ion is formed. Carbonium ion. Here the carbon have sp2 hybridization, okay, and have trigonal planar geometry. Okay, so due to having step 2, okay, due to having trigonal planar geometry, okay, so the nucleophile may attack the this carbon atom, carbonium ion from back side as well as front side. Nucleophile may attack from back side or it may attack from front side, because it have planar geometry. Due to having planar geometry, the nucleophile may attack from front side or it may attack from back side. That's why two products are formed in the SN1 reaction. One is inverted product, another one is retention product. Okay, so how many products are formed? Two products are formed in SN1 reaction. Okay, so one with inverted configuration, another one one is inverted product, another one retention product. Okay, so these two are mirror images to each other. So these are called as what? Enantiomers. These are called as what? Enantiomers. Okay, so the formed products are mirror images to each other. Non-superimposable mirror images are the formed. Okay, so these are called as what? Enantiomer. Okay, so both products are formed. Okay, among these two, inverted product will be somewhat more in concentration. Okay, so mainly racemization, it is called as what? Racemization. Okay, so racemic mixture is formed in the SN1 reaction. Okay, racemic mixture is formed in the SN1 reaction. Okay, so the enantiomers or racemic mixture is formed in the SN1 reaction. Okay, so here the nucleophile attach the carbon atom from the back side as well as front side. Okay, so that's why how many products are formed? Two products are formed, one with inverted configuration, another with retention configuration. Okay, so that's why how many products are formed? Two products are formed. Racemic mixture is formed in case of which reaction? SN1 reaction. If you see the reactivity order, the order will be like this. The order will be, in case of order of reactivity will be like this. Okay, so first benzyl cation, after that allyl cation, after that tertiary aldehyde, after that secondary, after that primary, after that methyl. Okay, so this is the order of reactivity in case of SN1 reaction. Here benzyl cation. So okay, benzyl cation have resonating structures. Okay, so it forms resonating structures. That's why it readily participates in the SN1 reaction. After that allyl cation. Okay, this also forms resonating structure. After that tertiary carbonium ion. After that secondary carbonium ion. After that primary carbonium ion. After that methyl carbonium ion. Okay, so this is the order of stability of carbonium ion. Okay, so in the rate determining step, carbonium ion is formed. Okay, so the alkyl halide or halogen compound which form more stable carbonium ion, that readily participate in the SN1 reaction. That's why the order of reactivity in case of SN1 reaction will be like this: benzyl cation greater than allyl cation, after that tertiary alcohol, after that secondary alcohol, after that primary alcohol, after that CH3 methyl bromide. Okay, so this is the order of reactivity. And also in this reaction also, SN1 reaction also, so greater the ability of leaving group, greater will be the order rate of reaction. And as the nucleophile strength increases, as the strength of nucleophile increases, the rate of reaction also increases. Okay, and in case of SN1 reaction, polar solvents favor the reaction, because here the polar solvent increases the ionization in case of first step. Okay, so the alkyl halide readily ionizes to form carbonium ion. That's why we use polar solvents in case of SN1 reaction. Okay, so this is about substitution nucleophilic reaction. Okay, so we will discuss about another type of reaction in next class. Okay, so till then, take care, bye.